This is problem number 4 on the practice problems for test number 1. The number of moose in Massachusetts is growing at the rate of f of x equals 10e to the 0.03x, where f of x is measured in moose per year and x is measured in years since the year 2000. Part A, what was the moose population in year 0? Okay, this formula we're looking at is a rate of change. In some sense, it is a derivative. So can we know anything about the original function in terms of a value? We can't. This is actually quite similar to the very first problem in this practice test, where the formula that we had, it wasn't giving us the rate of change of number of moose, it was giving us the rate of change of amount of water in a reservoir. And we can figure out by how much the amount of moose or water changes, but we can't pull out of a hat how much is in there to start either experiment. Part B, how fast was the moose population growing in year 0? Okay, so how fast? That's a rate of change. The function f is a rate of change. This problem is asking us to find f of 0. 10e to the 0 is 10 times 1, or 10. Let's include units. Moose per year, possibly the best unit. Part C, what was the average rate of change of f of x between year 0 and year 10? Give the units of your answer. Okay, the phrase average rate of change is supposed to cue you into a formula. So let's write that formula. Average rate of change, so I'll call that rate of change average, is equal to f of b minus f of a divided by b minus a, where a and b are the 2 points that you're trying to find the average rate of change between. So the 2 points in this case are 10 and 0. So we want f of 10 minus f of 0 divide 10 minus 0. Okay, if you plug f of 10 into the formula, and then you can use your calculator. Well, I'll just write it here. So it's 10e to the 0.03 times 10 minus, and then we've already done f of 0. It's right up above. It's 10. Downstairs is 10 minus 0, so that's also 10. And then if you crunch all these numbers together, you get about 0.35. And let's include units. So the best way to find units is to just look at the formulas that you plugged into. So the numbers up in the top here were in F units, and the numbers in the bottom, 10 and 0, those were years, right? So upstairs we've got F units, and downstairs we have years. So it's going to be something per year. So all we need to do is upstairs put the F units, and the F units were given in the problem was moose per year. So that means that this 0.35 is in moose per year, per, and then on the bottom was years. So moose per year, in some sense an acceleration of the moose population. Part D, by what percent is the rate of growth of the moose population growing continuously each year? Okay, so we got to be really careful with what the question's asking. So the rate of growth of the moose population, that's a phrase that we've seen, or it's almost exactly this phrase right here, growing at the rate of. So that underlined thing is F. That's describing F. So this rate of growth right here refers to F. So that's just F. But then the very next word tells us we got to do something else. At what rate is it growing? How is F growing? By what percentage is F growing? So how do we figure out by what percentage something is growing? Well, we got to take a derivative. How something is increasing or decreasing is certainly related to its derivative. So this problem is really asking us to find f prime. So f prime of x equals 10 stays, it's a constant multiple, e to the stuff, you copy, and then times the derivative of the stuff. The derivative of that power right there is 0.03. So pushing the 10 and the 0.03 together, we get 0.3 e to the 0.03 x. So that right there is the derivative. And we want to know by what rate is the population growing continuously each year. So the question is now really just saying, how is this function right here growing in terms of being a continuous growth percentage? And hopefully that formula right there reminds you of something like PE to the RT, or maybe, I don't know, other letters have been used in different books. Maybe something like A0E to the KT. Hardly matters. What you need to know is that the R, or the K, or the 0.03 is the rate in question. So the answer to this question is 0.03, but we want to write that as a percent, so 3%. Okay, finally, E. Let f of x be the moose population in Massachusetts as a function of years since the year 2000. Suppose f of 0 equals 300. Find the formula for f of x. Okay, so let's give this a shot. Looking for f of x. We know that the formula for f of x, we're looking for the actual moose population. How do you get it given the rate of change of the moose population? Well, you take an integral. So this is the fundamental starting point for us. So this problem is really asking us to integrate 10e to the 0.03x. Okay, how are we supposed to do this? Well, integrating e to the 0.03x is a u substitution. We're going to let u equal 0.03. Maybe pause the video here because I'm not going to go through the details of this u substitution, but come back when you've got that integral done. Okay, so hopefully you ended up dividing by 0.03 at the end of this. So let's see. So this guy turns into basically 333 and some change, e to the 0.03x plus c. So we're good here, except we still need to find c. So we haven't used one important fact here, and that's that f of 0 is 300. So now we're ready to use that fact. So f of 0 is 300. So 300 must be equal to this bottom black line. But instead of x, we're plugging in 0. And anything to the 0 is 1. So we've got enough to find c. So this basically says that 300 is equal to 333 and change plus c. So subtract the 333 from both sides, and we get negative 33.3. And now we'll just rewrite our final answer. See if we can get it on the screen. Oh yeah, right there, that black line at the top. So our final formula here is f of x equals 333.3, repeating, e to the 0.03x, plus the constant. The constant turned out to be negative 33.3, repeating.